All right, so this is 5.6, solving log and exponential equations. First of all, we're going to do the log equation with log on one side. This is the simpler type. For example, something like this. Remember, log equation is when your argument is the x, okay? You're looking for the argument here. And when you do this, first you have to look for the domain. Remember, the argument of log cannot be 0 or negative, right? Because 2 to the anything got to give you a number that is larger than 0. So your domain is, you take the argument here, x minus 1 has to be larger than 0. And you solve for that, then your x has to be greater than 1. Okay? You need that because when you solve for it, sometimes you get an answer that is not part of the domain, and that's extraneous. Okay, so here is the next step. I convert this into exponential form. Okay, then I have 2 to the third power is equal to x minus 1. Then that gives me 8 equals x minus 1. Then x is equal to 9. And I check here, is this in the domain? Is it larger than 1? Yes, it is. So that is a solution. Okay, let's do one where you might have an extraneous solution here. Okay, so I have log base 3 of x squared is equal to 4. I do the domain. I take the argument, which is x squared has to be larger than 0. And I square root both sides, right? So x has to be larger than 0. Okay, now I change to exponential form. I have 3 to the fourth power is equal to x squared, which gives me 81 is equal to x squared. And I square root both sides. I get x is equal to 9 or negative 9. But I look back at the domain here, x has to be larger than 0, so negative 9 doesn't work, right? I have to cross that out. So my solution is only x is equal to 9. Now, if you have log on both sides, you solve it slightly differently, okay? Something like this. You still have to do the domain. So look at the argument here. X has to be larger than 0. And there's no x here, so you don't have to worry, right? X has to be larger than 0. So here, I would move the exponent here, the number in front, to become the exponent, right? That's a property of log, right? You can move it, the exponent can move down to multiply, or the number in front can move up to become an exponent again. The whole point of doing that is so that I can have just log base 5 on both sides. You see how now both sides have log base 5, log base 5. If both sides are log base 5 of something, and they're equal, then that something must be equal. So log base 5 of x squared equals to log base 5 of 9. You see how everything is the same. That means that x squared has to be equal to 9. Okay, so one more time, if your log are equal on both sides, same base on both sides, then the arguments must be equal. X squared must be equal to 9. Then I solve that. X has to be equal to 3 or negative 3. And I check back with my domain. X has to be larger than 0, so I cannot have x equal to negative 3. I cross that out. X is equal to 3 only. Another example, I have log base 5 of x plus 6 plus log base 5 of x plus 2. Here I have two log of the same base. One more time. Log of the same base. I combine them. Another property of log here. This becomes log base 5. Oh, whoops. I'm going to do the domain first. So x plus 6 is greater than 0. That means that x has to be greater than negative 6. Then I have to do the other argument here. X plus 2 is greater than 0. That means x has to be larger than negative 2. Now you look at these two here. These two requirements says x has to be larger than negative 6 and x has to be larger than negative 2. That means that negative 6 becomes invalid, right? Because it needs to be greater than negative 6 and greater than negative 2. So anything that's greater than negative 2 will work, but anything less than negative 2 won't work, even if it's greater than negative 6. It's kind of like saying, to do this, you got to be older than 10 and you got to be older than 20. Well, then if you're 11 and 12 and 13, you're older than 10, but you're not older than 20, so it doesn't work. So it only works if you're older than 20. So that's how we look at this, okay? It needs to be greater than negative 6 and greater than negative 2. So negative 5, negative 4, negative 3, that's greater than negative 6, but it doesn't work. It has to be greater than negative 2. So we don't even worry about the negative 6 anymore. The domain is only when x is greater than negative 2. Then we solve for this, okay? Use the property of log. This becomes log base 5 of x plus 6 times x plus 2. You can multiply the argument here because you're adding log of the same base. Then you switch to exponential form because now log is only on one side. So 5 the first power is equal to x plus 6 times x plus 2. Multiply it out. You have 5 is equal to that trinomial, and then solve it by subtracting 5, make it equal to 0, factor it, and I have x is equal to -1 or -7. And I look back at my domain, x has to be larger than -2. Which one's larger than -2? The -1, right? Not -7, so I crossed out the -7. My answer is x is equal to -1. Here you have some like a combination of both log on both sides, and you have to combine some logs here. So they're all log of the same base. Log same base. This is base 10, by the way, if you don't remember. If you don't write base for log, it's 10. So I want to make these all just log only. So I move the 2 to the become x squared here, right? Oh, I keep forgetting. I do domain first. Okay, so the domain is you take it this argument, x is greater than 0, and I take this argument, 3x minus 4 is greater than 0. So x has to be larger than 4/3. So I don't care about the 0 anymore, right? My domain has to be larger than 4/3. Okay, because larger than 0 doesn't matter unless it's also larger than 4/3. Okay. Now I do the properties of log. I have log of x squared because the 2 goes to the front. And over here, I combine these, right? Same log, so you adding, so you multiply the argument 2 times 3x minus 4. That gives me log x squared. I distribute the 2 in, so 6x minus 8. Now, they're both the same log on both sides, so the arguments have to be equal. So x squared is equal to 6x minus 8. And that becomes a trinomial, a quadratic. You factor and you solve. So x is equal to 2 or 4. Which one is larger than 4/3? Because both of them are larger than 4/3. Both of them are the answers. Okay, you have two answers here. I think we have this might be the last one of this type. Here you have ln of x equals ln of x plus 6 minus ln of x minus 4. See, all of them are ln, same base, same base, same base. So you can combine these, right? But let's look at the domain first. So the first one is x plus 6 has to be greater than 0. So x has to be greater than -6. And then the other one is x minus 4 is greater than 0. So x has to be greater than 4. And also this one here, x has to be greater than 0. So we have x greater than 0, x greater than -6, and x greater than -4. I mean positive 4. So only the positive 4 works, right? So greater than -6 and greater than -4. No, greater than -6 and greater than 0 don't matter because they're smaller than 4. So they have to be greater than 4. So that one doesn't work. Your domain is anything that is bigger than 4. Okay, now we do the properties of log here. You combine these, right? ln of x is equal to ln of x plus 6 over x minus 4. So x has to be equal to x plus 6 over x minus 4. You cross multiply here. Make sure you guys know how to solve this type of equation, right? Just cross multiply. Have x times x minus 4 equals to x plus 6. Then you FOIL it in, or you distribute it in, and then that becomes a quadratic, right? Make it equal to 0, move everything to one side, factor, and solve. I have x is equal to -1 or 6. So which one is in the domain? It has to be larger than 4. So not -1. So x is equal to 6 only. Oh, okay, this might be the last one probably. So here log base 6 of something minus log base 6 of something equals to 2. See, they're both log base 6, so there you can combine them, right? But do the domain. 7x minus 2 is greater than 0. So that means x has to be larger than 2/7. And then over here, x plus 9 is greater than 0, so x has to be greater than -9. You see, greater than -9 won't matter anymore. It has to be greater than 2/7. And you solve this by combining these now, because their subtraction becomes division, right? Becomes division. Now, 6 to the second power, I switch it to exponential form because there's only log on one side. So 6 to the second power is equal to this. And then you solve from this is easy, right? Cross multiply and all that, right? And then I have I have that twice. And then you multiply it in. 36 plus 324 equals to 7x minus 2. And then solve for x. I get x is equal to -326 over 29. Now, my solution says that x has to be greater than 2/7, positive, right? This one is negative, so it's not part of the domain, so you actually don't have an answer. So you actually have no solution for this one, okay? Now we're talking about exponential functions. Something like this is really simple, right? You have something like this, you can just change this log form because you're looking for the exponent. That's what log does for you. Now remember, if this is like 2 to the x is equal to 8, you can just do that in your head, right? Because 8 can be changed to match the base 2 and 2, you know, if that 5 was an 8. But that 5 is a 5, and you can't match 2 and 5, so you just change it to log and use a calculator, basically. And here, what we do is we have to use the change of base formula, because the calculator can't do log base 2. So the change of base formula says log base 2 of 5 is equal to log 5 over log 2 equals to x. And here, if you really want to know the decimal value, then you plug it into the calculator. If not, you can just leave like this: log 5 over log 2. If you have exponents on both sides, all right, if you have variables on both sides of the exponent, here is the new skill that you got to learn, is that you ln both sides. All right, you ln both sides, so you have ln of 3 to the 3x plus 2 equals to ln of 5 to the x minus 2, and then you move the exponent to the front, right? That's a property of log. Move the exponent to the front, so I have 3x plus 2 times ln 3, and then x minus 2 times ln 5. And then ln 3 is just a number. It's like 1.1. And ln 5 is 1.5. And then you distribute that in, you solve for x. I'm not going to go through all the steps here. You guys should be able to solve this now. Okay? But that's the gist of solving this type of equations. Here is also a new type of problem that you really need to learn. Most likely you will see this one on the test for sure. So here you have something like this. And the trick is recognizing that the 4 and the 2 can be changed into the same base. Now, don't worry about the last number because it won't matter too much. Okay, so the 4 and the 2 can be changed to the same base. The base is 2, obviously, right? So I'm going to try to make that 4 into a 2, which is 2 squared, right? Ash. Okay, so I changed the 4 into a 2 squared. So 4 to the x has become 2 to the 2x, right? And then it looks something like this. I kind of made this in the wrong order, but it looks like this. 4 is 2 squared, right? And 2 squared to the x is equal to 2 to the 2x. See, now they have the same base, 2 and 2. So I just have 2 to the x squared. I just flip the two numbers around here. It's just manipulation. Nothing has changed. I just wrote it differently. The whole point is that I want to make this into the 2x here. Make them match. Okay, I want to match the 2x, 2 to the x, and the 2 to the x here. If they're the same now, I can do something called the u substitution. Okay, I let that thing that looks the same, the 2 to the x, equals to u. And I replace that with u. So I have u squared, because that's 2 to the x squared, minus u, because that's 2 to the x, minus 12. Now that looks like a quadratic. Okay, so this problem seems very gimmicky, but it's a strategy that we use a lot in math, in trig, and in calculus, solving for this type of equation. We use u. If we make it look the same, we can substitute with a new variable and solve for that. It makes it simpler. Okay, now you have a quadratic, which is very simple to solve. I factor u minus 4 times u plus 3 equal to 0. Right, and then u is equal to 4, or u is equal to negative 3. Now, I'm not looking for u, I'm looking for x, so I have to plug the 2x back in for u. Right, so I have 2 to the x equals 4, and 2 to the x equals negative 3. Well, here 2 to the x is equal to 4, x has to be equal to 2, right? And there is no number that I can raise 2 to get negative 3. Okay, so this second equation has no solution. So I have x just equal to 2. We'll do one more because I think that might have been confusing for you guys. So we'll do one more that looks kind of like that. You see how this is e to the x, and this is e to something. See, I'm going to try to match this with the e to the x. So this is just e to the x squared, right? Because e to the 2x, you see. Now I have these matching. I'm going to substitute them with u, right? So now I have e to the x equal to u. So I substitute that u in. U squared minus u minus 6 equal to 0. Then factor and solve. I have u is equal to 3 or u is equal to negative 2. Then I substitute this back in. E to the x is equal to 3 or e to the x is equal to negative 2. There's no x that will give me negative 2 when I raise e to the x. Okay, so the second equation has no solution. So the first one is e to the x equal to 3. That has a solution because it's positive. You can do it. Um, so this one, ln of negative 2 here, I just wrote that out for you to see that the argument of ln is negative 2, so no solution for this one. But this one, ln of 3 is equal to x. Okay, so this one has no solution because the argument is negative. But x is equal to ln 3 then. And if you want decimal, just put it into the calculator.